Hello everyone, myself Madhuri Venkatesh Sindam. I am Assistant Professor in DBF Dayanand College of Arts and Science, Solapur. Today I will be delivering a lecture on the topic of Mossbauer spectroscopy. Content, that means some point of Mossbauer spectroscopy will discuss in this lecture. That is introduction, principle, Mossbauer effect and Doppler effect, instrumentation of Mossbauer spectroscopy. First of all, introduction of Mossbauer spectroscopy. Mossbauer spectroscopy, it is also called nuclear gamma resonance, denoted by NGR. Mossbauer is a name of scientist Rudolf Mossbauer, who during his PhD work discovered this particular effect known as Mossbauer effect. Mossbauer spectroscopy is a versatile technique that can be used to provide information in many areas of science such as physics, chemistry, biology and metallurgy. In 1958, he discovered the recoil-free emission and absorption of gamma rays by nuclei. He awarded Nobel Prize in 1961 in physics. Now, principle of Mossbauer spectroscopy. We know the meaning of spectroscopy. Spectroscopy is the study of interaction between electromagnetic radiation and sample. And resulting this interaction, there is nuclear transition takes place. Similarly, in Mossbauer spectroscopy also involves a nuclear transitions which results from the absorption of radiations by the sample. But that radiation must be gamma rays. Simply, it is the study of gamma rays emission and subsequent resonance absorption. The Mossbauer spectroscopy technique uses a combination of two important effects known as Mossbauer effect and another is Doppler effect. We will discuss about Mossbauer's effect. Before that, we must know what is meant by recoil. When a high energy particle or projectile is released from a body at rest, the releasing body feels a back kick, that is, it is pushed backward, which is called recoil effect. Now, the most important point in Mossbauer spectroscopy is Mossbauer effect. In Mossbauer effect, it involves the resonant and recoilless or recoil-free emission and absorption of gamma radiation by atomic nuclei bound in a solid is called Mossbauer effect. The Mossbauer effect, also called recoil-free gamma rays emission resonance absorption. Mossbauer effect requires the use of solid or crystals. The gaseous and non-viscous liquids do not exhibit Mossbauer effect because of recoil energy loss. Now, the another important effect is Doppler effect. If consider E will be the energy, E0 is the energy in a ground state and R is the recoil energy. Then for emitting nucleus, the energy is E equal to E0 plus R, and for absorbing nucleus, the energy is E equal to E0 minus R. Therefore, delta E means line width is equal to 2R. Hence, the emission and absorption line will be 2R apart as shown in this figure. Thus, in order to have resonance absorption, the line width must be equal to or greater than that of loss of gamma rays energy due to recoil. And the Doppler shift is the change in frequency or wavelength due to moving source and absorber. That is, the higher the frequency will be the shorter wavelength and the lower the frequency will be the longer wavelength. Now, the next point is formation of Mossbauer nuclides. That means preparation of source nuclides. In Mossbauer spectroscopy, in which use a different sources with respect to sample. Mossbauer spectroscopy requires the use of solid or crystals, which have probability to absorb the photon in recoilless manner. Many isotopes exhibit in Mossbauer characteristic. For example, iron, ruthenium, tin, iodine, tungsten, iridium, gold, gadolinium, dysprosium, terbium, ytterbium. But the most commonly studied isotope is iron 57, and this iron 57 nuclides is obtained from electron captured by cobalt 57. This half-life time is 270 days. Consider a cobalt 57. Cobalt 57 is a radioactive material. It internal converts to iron 57. So let us look at the ground state and first excited state of the iron 57. This is a ground state and this is first excited state of the iron 57. The spin of ground state is 1 by 2 and the spin of first excited state is the 3 by 2 here. When cobalt 57 converts to iron 57, then its decay, if iron nucleus is in the first excited state to the when it decay to ground state, then it will be emit a gamma rays that is about 14.4 kilo electron volt emit a gamma rays. Then our electronics will just pick up that gamma rays. So this is known as source. Now instrumentation of Mossbauer spectroscopy. First of all, we know the principle, that is Mossbauer spectroscopy involves nuclear transitions which results from the absorption of gamma rays by the sample. In fact, it is the study of gamma rays emission or recoilless emission and subsequent resonance absorption. That means Mossbauer spectroscopy consists of recoil-free source. This is schematic diagram of Mossbauer spectrometer. If we have source of cobalt 57 radioactive material, it is all time giving the 14.4 kilo electron volt gamma rays, means in which a piece of cobalt 57 is mounted on a screw thread, which when rotated gives a steady velocity drive to source. The material under study, that means those material for which we want to know where electronic configuration or arrangements or crystal arrangements, all those things, and solid that we want to study, that solid is placed in between source and detector. That is known as absorber, and this solid must be contain iron 57 in ground state. When sample absorb gamma rays from source, then sudden fall in the count rate is observed by the detector, that is Geiger counter, which is placed behind the sample. This detector to count these gamma rays, how many gamma rays are coming in a given time. The signal from the detector is allowed to feed through a single channel analyzer. Single channel analyzer to refer single signal at a given frequency. Then it passed to multi-channel analyzer synchronized with the signal generator. Hence, a number of sources are required which have 100 different relative velocities of source and samples. The results from each source are collected and analyzed. It takes several minutes to few hours to record computer spectrum. Thank you.